So like we looked at in the first video, here is your greatest integer function, and I told you we'd be working more with that. And this is an example of a step function like we talked about, and it just looks like you can walk up the steps. It looks like a set of stairs. And so this particular function is the most famous, the most used of the step functions. And symbolically, it has kind of these double brackets, if you want to think about it that way. And then the way that you find it, the definition of that is whatever our x value is, we find the greatest integer that is less than or equal to x. Okay. For example, let's look at our examples here. If I have a -1 in here, -1 is an integer, so my answer is -1. Okay. Now, none of the rest of these are integers, so none of the rest are going to stay the same. So if I have -1/2, we're looking for the greatest integer that is less than or equal to that. And less than or equal to -1/2 is -1. It's like you're just moving backwards on the number line until you hit a whole number. So if I just draw a number line here, maybe we can use that as a little bit of a reference. See, all of these are between 0 and 2. So 0, 1, 2, -1, -2. So for our -1/2 would fall here. And so if I go backwards to the closest whole number, it would be -1. So that's where that answer comes from. So now I have 1/10, positive 1/10. We'll do that one, different color here. So positive 1/10 would be about like right after 0. So if I go backwards to the biggest whole number, that's 0. So 0 would be my greatest, let's see, what are we calling them here? Greatest integer function. All right, and then we've got 1/2. So if I go to the point 1/2 and I go back to the nearest whole number, that answer is 1. And again, if I go to 1.9 in our last example here, 1.9 is really close to 2. And even though it's close to 2, I'm still going backwards to the nearest whole number. So that's still considered an answer of 1. So that's the idea behind these. You go backwards on the number line to the closest whole number. It could be positive, it could be negative, doesn't matter. So one more example, if we just throw on here, if we had -1.7. Okay. Then -1.7 would be about here, and I would go backwards to get my answer of -2. So there's another example in the negatives. All right, so what does that graph look like? Well, what that means is any x value from +1, so let's see, let's do blue here. Anything from 1, right below 1, to 0, that answer is going to be 0. Anything between 1 and 2, the answer is going to be 1. Anything between 0 and -1, oops. Anything between 0 and -1, the answer is going to be -1. So that's how it creates. If we look over at the graph, remember we said anything between, what color did we use for that? So if I zoom out here, we used blue here where we looked at everything between 0 and 1. The answer was going to go to 0. Here, anything from 1 to 2, the answer was going to go backwards to 1. Anything from 2 to 3, the answer is going to come backwards to 2. And so that's why it is a stair step, because your output is always a whole number. Your output is either 1 or 2 or 3 or -1 or -2 or -3 or -4. But there's no in between. Notice there's nothing in between these. That's why they look like stair steps. Okay. So let's go ahead and evaluate and graph a function. So we're going to evaluate for these 3 values here, and then we're going to graph it. So to evaluate, my f of -1, if x is -1, would be the greatest integer from -1 and then +1. Well, whenever you're given a whole number inside here, that is your answer. If you already have a whole number, that doesn't change. So this would be -1 + 1. So f of -1 would give us 0. And then if we did f of 2, same thing. When we take the greatest integer value of 2 and then add 1, since you already have a whole number here, that's going to stay. So this would be 2 plus 1. So f of 2 would be 3. And then what do we have? F of 3 halves, and I'm going to write that as 1.5. So f of 3 halves is f of 1.5 because it's just a little bit easier to picture that way. And so that's going to be the greatest integer value of 1.5 and then plus 1. So here we don't have a whole number, we have a fraction. So we're going to go backwards to the nearest whole number. So if I'm at 1.5, I'm going to go backwards to 1, and then I'd have 1 plus 1. So f of 3 halves is positive 2. So there's my three values. We got 0 for f of -1, we got 3 for f of 2, and we got 2 for f of 3 halves, or 1.5. Now to graph this function, we know it's going to look like stairs. Okay? It should look like stair steps. Okay. So I'm going to bring in a graph. All right, so here's my graph, and then I can go ahead and plot the points that I have. So f of -1 is 0. So at -1, I know the y value is 0. I'm just going to put a little point there. And then f of 2 is 3. So at 2, it's 3. And then f of 1.5 is 2. So at 1.5, I'm going to be at 2. Okay? But that doesn't give me my stair steps. But I can use that because, remember, these should go from whole number to whole number. So this chunk that I have here, if we start, let's start in the middle here. Let's start at our 1.5 and our 2. What that means is everything from 2, from 2 up until 3 should be that value. So notice, oh sorry, from 1 to 2, from 1 over to 2, and then notice there's an open circle on 2 because my equal to 2 is up 1. So this gives me my pattern for my stair steps. So I can go ahead, I'm going to erase that. That means that my next stair step is going to start up at 3, and it's going to go on 3 until the 3 here. Then we're going to jump up to 4 because we're adding 1 every time. And that's going to bring us over to the 4 and so on. So just from the graph that I have, I can go ahead and finish. So when you're graphing these, what you need to do is find a few points and find some that are fractions. So I'm going to go ahead and bring my graph backwards here and finish my graph. But then I'm also going to show you, there's a point we already had. I'm also going to show you how to do this if you were just told to graph, if you didn't have to find those three values like we did first. Do a couple more here. There'll be a pattern that follows. There we go. So there's my graph. Now, if you did not have to do this part, if you didn't have to find those values, because this is what we use to graph, what you can do is just make your own table of values. So if this is our function, our greatest integer, and then plus 1, you could just make an XY table and pick a few different values. Pick some positive, pick some negative. So what I would do is I would do like -1.5, -1, -1/2, kind of go by halves and then do a 0. And then you could do a positive. Maybe I do 2 and then I do 2.5, and then just figure out what those outputs would be over here. And then use those to figure out what your graph is going to look like, because it'll always have this pattern of having those steps. It'll always start with a closed circle because you want it to equal the smaller number, and then it'll always end with an open circle like this. So you'll always have that pattern, and you can use a table of values to figure out what it's going to look like.